Right now, as you watch this, something is happening in our solar system that we cannot fully explain. On October 29, 2025, at precisely 11:36, Coordinated Universal Time, an object designated 3I/Atlas will reach perihelion, its closest approach to our Sun, passing at a distance of 1.356 astronomical units, roughly 203 million kilometers from the solar surface. For 8 days leading up to this moment, from October 21st through October 29th, this visitor will be positioned directly behind the Sun from Earth's perspective, completely hidden from our telescopes, unobservable, invisible to humanity's most powerful instruments. A solar conjunction at the exact moment an interstellar traveler reaches its point of maximum solar gravitational influence. That timing is what keeps me awake at night. Here is what makes this impossible to ignore. 3I/Atlas is not some random asteroid tumbling through the void. This is the third confirmed interstellar object ever detected entering our solar system, following 1I/Oumuamua in 2017 and 2I/Borisov in 2019. It was first spotted on July 1, 2025 by the Atlas Survey Telescope in Chile, part of the Asteroid Terrestrial Impact Last Alert System, when it was 4.5 astronomical units from the Sunday pre-discovery observations from the Zwicky Transient Facility at Palomar Observatory, archived data from 3 separate Atlas telescopes around the world, and even fortuitous images captured by the newly commissioned Vera C. Rubin Observatory pushed the detection timeline back to mid-May 2025. By the time astronomers confirmed its hyperbolic trajectory, its orbital eccentricity of approximately 1.000016, they knew with absolute certainty this object originated beyond our solar system and would eventually leave it forever. Its velocity when discovered was 137,000 miles per hour, 61 kilometers per second, far too fast to be gravitationally bound to our Sunday. The International Asteroid Warning Network, a worldwide planetary defense collaboration that monitors potentially hazardous near-Earth objects, designated 3I/ATLAS as the first interstellar object targeted by its formal observation campaigns. Think about that for a moment. An organization created to protect Earth from asteroid impacts is now coordinating a global effort to track something that came from beyond our solar neighborhood. IAWN announced a dedicated comet campaign running from November 27, 2025 through January 27, 2026, specifically to introduce improved astrometric measurement methods for this object. They scheduled a mandatory workshop for participating observers, with registration required by November 7th. The European Space Agency deployed its Mars Express and ExoMars Trace Gas Orbiter spacecraft to observe 3I/Atlas during its closest approach to Mars on October 3, 2025, when the object passed within roughly 30 million kilometers of the red planet. NASA's Mars Reconnaissance Orbiter, equipped with a high-rise camera capable of 30 km per pixel resolution at that distance, was repositioned to capture images. ESA's Jupiter Icy Moons Explorer spacecraft, currently on its way to the Jovian system, attempted observations in November using multiple instruments including cameras, spectrometers, and particle sensors, coordinating with NASA's Europa Clipper mission and its twin ultraviolet spectrographs. The Hubble Space Telescope imaged 3I/Atlas on July 21 and August 20, 2025, revealing a teardrop-shaped cocoon of dust and constraining the nucleus diameter to between 440 meters and 5.6 kilometers. The James Webb Space Telescope conducted its first observations with the NIRSPEC instrument on August 6, 2025, with additional observations planned for December after perihelion passage. This is not routine scientific curiosity. This is mobilization. Now let me translate what the data are actually telling us. Imagine you are standing in a dark room and someone across the room begins flashing a light at you, not randomly. The flashes have structure, they have direction, they have timing. That is essentially what 3I/Atlas is doing, except instead of light flashes, it is producing a highly directional jet of gas and dust aimed directly at the Sunday. Hubble's imagery from July captured this forward jet, a stream of scattered sunlight 10 times longer than it is wide, pointing toward the sun rather than away from it. Standard cometary behavior produces tails that stream away from the sun, pushed by solar radiation pressure and the solar wind. This is called an anti-tail, and while geometric projection effects can sometimes create the illusion of a sunward tail, the Keck Observatory observations from August 2025 confirmed this is a genuine anti-solar emission structure. Astrophysicists at the Teide Observatory, using the 2-meter twin telescope, documented this jet's morphology in October 2025, publishing composite images that overlay the jet vector against the anti-solar direction and the comet's velocity vector. The geometry does not fit standard outgassing models. Let me give you the numbers, because numbers do not lie, they simply are. 3I/Atlas has a minimum mass of 33 billion tons. That makes it 1,000 to 1 million times more massive than Oumuamua and roughly 1,000 times more massive than Borisov. Based on the statistical distribution of asteroid sizes in our own solar system and the detection rates of interstellar objects, the probability of discovering an object of this size before detecting a million smaller ones is approximately 0.01%. When it was first observed at 4.5 AU in July, it was anomalously bright for its distance, initially suggesting a diameter around 20 kilometers if it were a rocky asteroid with typical albedo. But that size distribution makes no statistical sense. We should not be seeing objects this large before we have cataloged hundreds of thousands of smaller interstellar visitors. The brightness had to come from something else, a coma, a cloud of gas and dust, cometary activity. Except the spectroscopy told a different story. Analysis from multiple observatories in July 2025 revealed something unprecedented. The object's spectrum showed no clear emission lines from typical cometary gases, no strong CN, no clear C2, no abundant water vapor signatures. Then, in August, the Keck Observatory detected emission features consistent with nickel-bearing compounds in the coma, but found no corresponding iron emissions. Nickel without iron. In nature, these elements almost always appear together because they form together in stellar nucleosynthesis and remain locked in similar mineral phases. The nickel to CN ratio observed in 3I/Atlas is orders of magnitude higher than any known comet. When NASA's James Webb Space Telescope analyzed the coma composition in August 2025, it detected carbon dioxide, water vapor, carbon monoxide, carbonyl sulfide, and water ice. But here is the critical finding. The carbon dioxide to water ice ratio is 8:1. Most solar system comets have water as the dominant volatile, typically comprising 70 to 80% of their ice content. 3I/Atlas has only 4% water content. It is basically a frozen carbon dioxide snowball from another star system, activated by dry ice sublimation at distances where normal comets remain dormant. Observations from NASA's Transiting Exoplanet Survey satellite from May 7 through June 3, 2025, when the object was approximately 6.4 AU from the Sun, showed it was already bright and active, confirming that volatiles far more reactive than water were driving its behavior. Here is the terrifying part. 3I/Atlas is traveling on a retrograde orbit, meaning it circles the Sun in the opposite direction from all the planets. Its orbital plane is inclined only 4.89 degrees from the ecliptic, the flat disk containing Earth, Mars, Venus, Mercury, Jupiter, Saturn. For an object arriving from interstellar space from a random direction in the galaxy, the probability of such precise alignment is approximately 0.2%. Oumuamua arrived at an inclination of 123 degrees. Borisov came in at 44 degrees. Those are normal. Those are random arrivals from the galactic stellar population. 3I/Atlas is not random. It is flying along the planetary highway. Some have pointed out that objects originating from the Milky Way disk might preferentially arrive near the ecliptic plane. This argument does not hold. The ecliptic plane is misaligned relative to the galactic disk by roughly 60 degrees. That misalignment is more than 10 times larger than 3I/Atlas's inclination. The local velocity dispersion of stars in our galactic neighborhood is roughly isotropic, comparable within a factor of 2 in all directions, due to epicyclic motion perpendicular to the disk. Interstellar objects should arrive from all directions. This one did not. And then there is the arrival direction. The trajectory of 3I/Atlas, when traced backward through space, originates from a region of sky within 9 degrees of the source of the famous WOW signal detected on August 15, 1977, by the Big Ear radio telescope at Ohio State University. That 72-second radio burst at 1,420 megahertz. The hydrogen line remains the strongest candidate for an extraterrestrial transmission ever recorded. 72 seconds of a signal 30 times stronger than background noise, never repeated, never explained. Now, an interstellar object arrives from nearly the same celestial coordinates 48 years later. Coincidence has a probability. Stack enough low probability events together and you move beyond coincidence into pattern. Let me walk you through what we are actually looking at here. We have 8 documented anomalies, and I want you to understand each one individually before we consider them as a cumulative data set. First, the ecliptic alignment I have already described, probability 0.2%. Second, the anti-solar jet, inconsistent with standard geometric projection effects observed and confirmed by multiple independent observatories. Third, the mass anomaly, 1 million times larger than Oumuamua, 1,000 times larger than Borisov, statistically improbable as a first detection. Fourth, the planetary flyby trajectory, with close approaches to Mars at 30 million kilometers on October 3rd, Venus at 97 million kilometers on November 3rd, Earth at 270 million kilometers on December 19th, and Jupiter at roughly 46 million kilometers on March 16, 2026. Fifth, the nickel-enriched coma with nickel to CN ratios exceeding cometary norms by orders of magnitude and complete absence of iron. Sixth, the 4% water content versus the typical 80% found in solar system comets. Seventh, extreme negative polarization of reflected sunlight, unprecedented among comets, including Borisov, documented in photometric observations through September 2025. Eighth, the arrival direction within 9 degrees of the WOW signal source. Each anomaly, taken individually, can be explained. Comets are diverse, chemical compositions vary, geometric effects create optical illusions, statistical outliers happen. But here is where scientific skepticism must confront probability theory. These are not independent variables. They describe the same object at the same time. The cumulative improbability is what demands attention. Dr. Avi Loeb, former chair of Harvard's astronomy department and head of the Galileo project, developed a scale for assessing potential technological signatures in astronomical observations, ranking objects from 1 to 10 based on anomaly accumulation. 3I/Atlas ranks 4 out of 10 on that scale. Unusual but not conclusive. Natural comet hypothesis remains the baseline. But a rank of 4 justifies systematic follow-up because the implications of being wrong are existential. Let me be very clear about what I am not saying. I am not claiming 3I/Atlas is artificial. I am not suggesting it is a spacecraft, a probe, an artifact of alien engineering. What I am saying is this: we have an object exhibiting a cluster of properties that do not fit comfortably within the known distribution of cometary characteristics, and it is doing so while positioned in a way that maximizes its interaction with our solar system's architecture. That combination demands rigorous observation, not assumption. Now I want you to think about timing, because in orbital mechanics, timing is everything. There is a maneuver principle in astronautics called the Oberth effect. When a spacecraft wants to change its velocity most efficiently, it fires its engines at the point of maximum orbital velocity, which occurs at closest approach to the massive body it is orbiting. An impulse in the direction of peak velocity, or opposite to it, maximizes the gain or loss of kinetic energy. For 3I/Atlas, perihelion on October 29th represents that optimal maneuver window. At closest approach to the Sun, with sunlight delivering more than 33 gigawatts of power to its surface, equivalent to at least 1/3 of the total power generated by 94 operating commercial nuclear reactors in the United States, this object will be experiencing maximum thermal and gravitational stress. If it is a natural comet, we should expect outgassing, possibly fragmentation, ejection of ice and dust as frozen volatiles explosively sublimate. If it is something else, if any component of it is designed rather than accreted, this is when we would see maneuvering or deployment. 3 hypothetical scenarios merit consideration, and I want to present them as exactly that, hypotheses that make testable predictions. Scenario 1, benign natural comet. 3 I/Atlas is an unusually large carbon dioxide-rich comet from another stellar system with exotic trace chemistry and coincidental geometric alignment. Post-perihelion observations through December 2025 and January 2026 should show continued outgassing, gradual brightening as it approaches Earth in mid-December, spectroscopic signatures consistent with passive thermal response to solar heating, and trajectory that remains on its predicted hyperbolic escape path, with no deviations beyond standard non-gravitational forces from outgassing asymmetry. This is the most probable scenario and should be the default assumption. Scenario 2, diagnostic instrument or automated probe. 3 I/ATLAS is a designed object conducting reconnaissance, deliberately timed to pass through the inner solar system along the ecliptic plane to maximize planetary encounters. The solar conjunction provides concealment during critical operations. Post-perihelion observations should show possible release of smaller objects that separate over subsequent weeks and months due to velocity kicks and solar tidal forces, potential trajectory corrections, inconsistent with cometary outgassing, emission signatures not matching known, cometary chemistry, and behavior suggesting active systems rather than passive response to environment. Scenario 3, something we have not considered. Science advances when observations defy existing categories. If 3 I/Atlas does not fit scenario 1 or 2, if it exhibits properties that remain anomalous even after comprehensive observation, then we are looking at a phenomenon that will require new physics, new chemistry, or new categories of objects that we did not know existed. This would be the most scientifically valuable outcome because it expands our understanding of what is possible in the universe. Here is what we need to watch for. The observational window reopens in early December 2025 when 3 I/Atlas emerges from behind the Sun and becomes visible again from Earth. Amateur astronomers with 8-inch or larger telescopes should be able to detect it in the morning sky around November 11th, though it will remain faint. The object will be in the constellation Sagittarius initially, moving against background stars. The International Asteroid Warning Network campaign begins November 27th and runs through January 27th, 2026. During this period, professional observatories worldwide will be taking coordinated, high-precision astrometric measurements to track any deviations from predicted trajectory. The key observables are these. Does the object's brightness curve match models of passive outgassing? Do spectroscopic signatures remain consistent with natural cometary chemistry? Does the trajectory show any non-gravitational acceleration beyond what can be explained by asymmetric outgassing? Do any new objects appear in the vicinity, separating from the main body? Does the coma morphology change in ways inconsistent with solar heating gradients? ESA's JUICE spacecraft, despite being on the far side of the Sun with degraded communication bandwidth, attempted observations in November 2025 and will download that data in February 2026. That 3-month delay means we will not have JUICE's multi-wavelength analysis until well after initial conclusions are drawn from Earth-based observations. NASA's Juno spacecraft orbiting Jupiter will have optimal geometry for observing 3 I/Atlas post-perihelion, potentially obtaining close-up imagery as the object passes near Jupiter in March 2026. The Hubble Space Telescope is scheduled for follow-up ultraviolet spectroscopy to measure the sulfur-to-oxygen ratio in outgassing and to monitor the object's evolution as it moves away from the Sunday. James Webb will conduct another observation campaign in December 2025 with enhanced spectral coverage to search for organic molecules, complex hydrocarbons, and any emission features that do not match known cometary ice sublimation. The fact that major space agencies are coordinating this level of observation is itself noteworthy. ESA, NASA, the International Astronomical Union, the Minor Planet Center, the International Asteroid Warning Network, these are not organizations that mobilize lightly. Their involvement signals that 3I/Atlas is being treated as a scientifically significant event, possibly a once-in-a-generation opportunity to study pristine interstellar material, or possibly something more. The silence from some quarters is also informative. High-resolution images that should have been released from Mars Reconnaissance Orbiter's HiRISE camera during the October 3rd flyby have not yet been made publicly available. Whether this is due to the recent government shutdown disrupting NASA operations, as some have suggested, or due to data quality issues, or due to more complex reasons, remains unclear. But the absence of expected data creates an information vacuum, and vacuums tend to fill with speculation. Here is what I think is actually happening, and I want to be precise about the degree of confidence I assign to each part of this assessment. With 95% confidence, 3I/Atlas is a natural comet from another star system with unusual but explicable chemical composition. Interstellar space is a cryogenic laboratory that produces exotic ices under conditions we cannot replicate on Earth. Regions dominated by carbon monoxide and carbon dioxide ice formation, perhaps in the outer regions of a protoplanetary disk around a star with different metallicity than our Sun, could produce exactly the kind of chemistry we are observing. The ecliptic alignment, while statistically unusual, is still possible, especially if there is some bias in how interstellar objects gravitationally scatter into the inner solar system versus how they are distributed in interstellar space. The size anomaly is a detection bias. We spotted this one because it became active early due to its exotic volatile mix, not because it represents a true size distribution of interstellar objects. By January 2026, observations will have confirmed steady outgassing, predictable trajectory, and chemistry consistent with a carbon dioxide-dominated comet from an extrasolar system. This will expand our understanding of planetary formation diversity across the galaxy. With 4% confidence, 3I/Atlas includes components or exhibits behaviors that cannot be explained by natural processes alone. This scenario requires several of the observed anomalies to persist after careful analysis for trajectory deviations to exceed what can be explained by outgassing asymmetry, or for spectroscopic features to emerge that have no match in cometary, asteroidal, or known mineral libraries. In this case, we would be looking at evidence of technological activity, which would be the most profound discovery in human history. The implications would be immediate and global. Every radio telescope on Earth would be reoriented toward this object. Every available spacecraft would attempt close approach if trajectory allowed. Protocols for contact scenarios would activate, though those protocols remain largely theoretical and untested. The scientific, philosophical, and societal impact would be transformative. With 1% confidence, 3I/Atlas will do something we have not anticipated, something that falls outside both the natural comet and technological artifact categories. Perhaps it will fragment in a way that reveals internal structure inconsistent with rubble pile accretion. Perhaps it will emit in wavelengths we are not currently monitoring with the right instruments. Perhaps it will interact with the solar wind or solar magnetic field in ways that give us new physics. This is the scenario where 3I/Atlas becomes a teacher, showing us that our categories are incomplete, that the universe has more variety than our models predict. But here is what you need to understand about probabilities. A 1% chance of a civilization-altering event is not a small risk. If I told you there was a 1% chance that an incoming asteroid would impact Earth, we would mobilize every resource we have to refine that probability and, if necessary, prepare a response. The same principle applies here. Even if the most likely outcome is a natural comet, the accumulated anomalies justify treating this as a potential contact scenario until that possibility is conclusively ruled out. This is not alarmism. This is risk assessment. The next 60 days are critical. If you want to stay informed as this situation develops, as new data emerge from JUICE, from ground-based observations, from the coordinated IAWN campaign, I recommend you subscribe to this channel so you receive updates on the timeline as events unfold. This is not hype, this is science in real time, and you are living through it. Between now and late January 2026, we will have answers to most of the outstanding questions. The trajectory will either stay purely gravitational or it will not. The chemistry will either match known comet models or it will not. The morphology will either evolve predictably or it will not. I want to leave you with a question, and I want you to think seriously about your answer. Are we alone in the universe? For most of human history, that question was philosophical, speculative, unanswerable. Now it is scientific. We have instruments, we have methods. We have a target moving through our solar system that we can observe in real time with ground-based telescopes, space-based observatories, and interplanetary spacecraft. If 3I/Atlas is natural, and I believe it probably is, then it still teaches us that planetary systems around other stars produce objects unlike anything in our own solar system, objects with carbon dioxide, ice ratios that would be impossible here, objects that challenge our formation models and force us to expand our understanding of cosmic chemistry. If 3I/Atlas is something else, if any component of it shows evidence of design, then we are witnessing first contact, not with biological entities, but with artifacts, with probes, with technology sent across the light years to explore other stellar systems the way we are beginning to explore ours. Let that sink in. Right now, as I record this, 3I/Atlas is behind the Sunday, hidden, unobservable, approaching perihelion. In 8 days, it will complete that passage and begin its journey back out into the solar system, becoming visible again to our instruments in November. By mid-December, it will reach its closest approach to Earth at 1.83 astronomical units, roughly 270 million kilometers away, still far beyond any danger, but close enough for detailed spectroscopic analysis. By March 2026, it will pass Jupiter and continue outward, eventually leaving the solar system forever, becoming just another wanderer in the interstellar medium, carrying with it whatever information it gathered during its flyby of our star. We will not get another chance. Interstellar objects pass through the inner solar system roughly once per decade based on current detection statistics, but we only started detecting them in 2017. Oumuamua was already leaving when we spotted it. Borisov gave us a few months of observation. 3I/Atlas is giving us the longest observation window yet, from May 2025 through March 2026. 10 months of data collection with the most advanced instruments humanity has ever built. This is our opportunity to do the science correctly, to follow the evidence wherever it leads, to remain skeptical while staying open to discovery. So I will ask you directly, do you think 3I/Atlas is just a comet, or do you think we are seeing something more? This is not a rhetorical question. Science advances through informed debate, through careful consideration of alternatives, through the tension between skepticism and curiosity. Leave your thoughts in the comments. Are we witnessing natural diversity in interstellar ice composition, a pattern-seeking bias, interpreting randomness as design? Or are we seeing the first real evidence that we are not alone? Because one of those answers is correct, and the data that will tell us which one are being collected right now. The next time you look up at the night sky, remember that somewhere out there, beyond the glare of the sun, moving at 61 kilometers per second on a hyperbolic escape trajectory, is an object that came from another stellar system. It traveled through interstellar space for hundreds of thousands or millions of years, crossing the void between stars, until it fell into our solar system and passed through our planetary neighborhood. Whether it is ice and rock shaped by natural processes we do not fully understand, or whether it carries some component of intentional design, we will know soon. The observations are happening, the data are accumulating, the answer is coming. And when it arrives, when we have analyzed the trajectory, the spectroscopy, the morphology, the timing, when we have accounted for every measurement and ruled out every alternative explanation, We will either confirm that the universe produces objects more diverse than we imagined, or we will confirm that we are not alone. Either outcome changes everything. Either outcome expands human knowledge in ways that will echo for generations. Either outcome is worth paying attention to. This is Michio Kaku, reminding you that we live in an era where the ancient question, "Are we alone?" has moved from philosophy to observational astronomy. The answer might be hiding behind the sun right now, waiting for us to look closely enough. And in 60 days, when 3I/Atlas re-emerges into our observational window, we will be looking. Stay tuned, stay curious, stay skeptical, and watch the data.